कल हमने अच्छा कल हमने जो किया था वो किया था कि I told you that there's a thing now I explained to you कि in transition metals all that we are studying here, that's the only thing that's going to be asked. So it requires a bit of my memorization, which is that you need to know that what a metal complex is, that this is what a metal complex is. You've got a metal ion, copper 2+ ion, and when you mix it in water, it gets surrounded by water molecules, and the lone pairs of the water are going to be attracted. They're going to be attracted to this copper 2+, and it's going to get surrounded by all sides. So what's going to happen is there's going to be 6 water molecules surrounding it, and that is known as a metal complex. The species with lone pairs, those species, the ones that have lone pairs, are your ligands. They're known as your ligands. They're the ones that are forming a coordinate bond or a dative bond with the copper in the middle. And it's known as an octahedral complex because of its shape. Shape is octahedral. 6 bonds, 1 bond on top, 1 at the bottom, 1 on the x-axis, bonds on the y-axis. So anyways, it's copper surrounded by 6 water molecule, and that's a blue colored solution. So you should know that copper dissolved in water, that's a blue colored solution. And the next thing is, okay, if you add NaOH to it, what happens is that when you add NaOH, then some of the water molecules are going to get knocked out, some of the ligands are going to get knocked out, and they're going to be replaced by OH ions. And that results in the formation of a very pale blue precipitate, which is this one, a solid precipitate. A crystal is going to be formed, which is very insoluble. It's copper hydroxide. So this is going to be formed. And then if you add ammonia to it, ammonia is a ligand. If it's added, what happens now is that the water molecules are going to get knocked out, and they're going to be replaced by ammonia. They're going to be replaced by ammonia, and it's going to form, and it could be any number of ammonia molecules, as long as the total number of molecules or ligands are that's 6. So there could be 4 NH3s and 2 water molecules, or maybe there are 5 NH3s or 1 water molecule, or maybe all 6 of them are NH3s. So any number of NH3 and water, as long as the total comes out to be 6. So in total, there's going to be 6. And this is a deep blue solution. This is the color of the solution. And then we had another one, which is that if you add concentrated HCl to it, then what happens is that Cl-1 knocks out all the water molecules, and Cl-1, they surround it. And this is a tetrahedral complex. This complex is known as a tetrahedral complex. Let me write that. This one is a tetrahedral complex. The reason it's called a tetrahedral complex is that the shape is obviously tetrahedral. You can't fit 6 Cl ions around it. Cl ion is a much bigger ion. It's got a much bigger ionic radius. So based on the size of the Cl ion, only 4 of them can actually fit around a copper ion. That's why, because you've got a bigger ligand, you can't really have a lot of them fitting around it. So that's another complex that you have to remember. Now these are ligand exchange reactions. The one with Cl-1, that's a ligand exchange reaction. That means one ligand gets, it's obvious, one ligand gets exchanged by another one. The one with ammonia, that's also a so that's also a ligand exchange reaction. That one ligand gets replaced by another one. So we need to write equations for this, the same thing. So you have to remember all of this. And exactly the same thing happens with cobalt. This is something that you should remember, that With copper 2+, you have all these Ligand exchange reactions. The same exact thing happens with cobalt as well. Same exact complexes and Ligand exchange reactions. Reactions are going to take place with cobalt. The only thing is that cobalt is going to have different colors. You're going to have cobalt with water, 6 water molecules, and this thing has a charge of +2. The only thing is that cobalt with 6 water molecules, that's a pink solution. Then you have cobalt hydroxide. That can also be formed. So it's going to have 4 water molecules and it will have overall no charge. That's going to be a green precipitate. Cobalt, if you add ammonia to it, cobalt gets surrounded by ammonia. So maybe there would be some water molecules and some of them will be ammonia ligands around it, or maybe all of them are ammonia. This one is a brown solution. And there's one more, that cobalt can also be surrounded by Cl lines, and it will form this complex CuCl4 2-, and this one is going to be a pink, not a pink, it's going to be a blue solution. Okay, so this one over here is going to be a blue solution. So same exact reactions. You have to remember this. For copper, the colors are different. For cobalt, the colors are going to be different. So you just have to replace this copper in the middle with cobalt and everything will be exactly the same, except that the colors of these solutions are going to be, they're all going to be different. Okay, is this clear? कि कोबाल्ट से भी के साथ भी यही याद रखना है. क्लियर है सारों को?
Yes, sir.
So then what you have, so the next thing that you have is, I mean, we're going to write equations for this. So the same reaction that we did. I'm going to start writing equations for the same reactions. So they're going to describe these reactions like this, that that, for example, they might give you a statement that a few drops of ammonia are added. But let's start with NaOH. I mean, describe what you would see with the aid of an equation. What would happen if a few, not a few drops, so a few drops of NaOH are added to copper sulfate aqueous. This is the test of cations that you've already done in IGCSE O levels. So a few drops of NaOH are added to copper sulfate aqueous. What you see is a pale blue precipitate formed, which is insoluble in excess. And that pale blue precipitate is insoluble in excess. So copper sulfate aqueous is this thing. Copper sulfate aqueous is copper surrounded by 6 water molecules. And it's got a charge of, the overall charge on this thing is +2. when you add OH ions, some of the water molecules get replaced by OH ions. So यहाँ पे there's a, you're going to have a reversible. So 2 OH, and we'll have 4 water molecules. And it's going to have a charge, 2 water molecules are going to get knocked out. This is, everything is aqueous. The NOH added was also aqueous. This is your solid, a pale blue solid is formed. And that water vapor is a liquid. So the same reaction that we did, I've just written down an equation for this. It's this one, where the 6 water molecules, some of them, they get replaced by OH ions. That's the reaction. Okay, and similarly, so is this clear?
Yes, sir.
और अब अगला ये कि then you had another test for copper ions, and that was that a few drops of so in the next one, what happens is that you OH is charged, but there's not going to be any overall charge. Like copper is 2 plus OH is -1, so overall the 2 OH ends, so the whole thing will be neutral. यहाँ पे obviously OH is charged. So the next part is a few drops of ammonia are added. So a few drops of NH3 are being added. And they're added to copper sulfate aqueous. Now, again, you get a pale blue precipitate. So when you add ammonia, a pale blue precipitate forms, which dissolves in excess ammonia. So it dissolves in excess ammonia, giving a deep blue solution. Now, what happens in this reaction is that when you add ammonia to it, the first thing that happens is that the ammonia reacts initially as a base. So your ammonia initially acts as a base instead of a ligand. What does a base do? The base accepts H plus one ions, right? Ammonia is basic. So this ammonia will go in the water. You're adding a few drops. So when a small amount of ammonia is added, it reacts with the water and it goes on to accept H plus one ions from water. So it becomes NH4 plus 1. Why can ammonia accept H plus one ions? Because ammonia has these lone pairs. And these lone pairs are going to, attract the H plus 1 from water, and OH ions are produced. So these OH ions, they get produced. So that's the first thing that happens. And these OH ions then act as ligands. So our OH ions with the lone pairs, they initially act as ligands. So although you've added ammonia, but ammonia is not the one that's acting as the ligand. The ammonia, the small amount of ammonia that you've added, is reacting with the water molecules to produce OH minus 1 ions, and you basically get the same reaction as the first one. So you get a pale blue precipitate. You get exactly the same reaction. The water molecules surrounding the copper, they get replaced by OH ions. So initially, the ammonia is not acting as a base. ठीक है, वो जो few drops add किए थे ना, the few drops, they ended up ionizing water. So ammonia is not initially behaving as a ligand. So is this clear that why you're getting a pale blue precipitate? Is this clear? Am I clear? See?
Yes.
So, but when you add ammonia in excess, that's when ammonia starts behaving as a ligand. So when your NH3 is added in excess, so then it starts acting as a ligand. So it acts as a ligand then. And this is what happens that, the same complex that we have over here, that same complex, the precipitate, the pale blue precipitate is going to dissolve. And it will start reacting with NH3. So maybe 4 NH3s. So it could be a variable number of NH3s. So let's take 4 NH3s. It could be all 6. 6 could be NH3s as well. And your copper then gets surrounded by NH3, giving a deep blue solution. There's only 2 water molecules left. And the overall thing will have a charge of +2. And the 2 OHNs are going to get replaced. And some of the water molecules are also going to get knocked out. So you got this reaction, that's your deep blue solution. Okay, so the same reaction, it's so is this clear? How would you explain all of this, that when a few drops of NH3 are added, you get a pale blue precipitate, and which dissolves in excess NH3, giving a deep blue solution. So initially, OHNs, they come in, you form a pale blue precipitate, and then that pale blue precipitate dissolves in NH3, and you get this thing over here. हाँ, इसके अंदर मैंने एक्सप्लेन किया था, ये अमोनिया वाला जो है ना, इसके अंदर मैंने स्पेसिफिकली एक्सप्लेन किया था कि I told you that it could be any number of NH3s. It could be all 6 could be NH3s, or they could be 4 NH3s or 2 water molecules, or maybe 5 NH3s and 1 water molecule. जो भी है ना, वो the total must be 6. ठीक है, Lisa, is this clear? तो वहां पे मैं I'll just for the sake of clarity, I'll just write an option that for the sake of clarity, I'll write an option where you could have, or I can write a general thing like I can have n NH3s and 6 minus n water molecules. The charge would still be +2 because both water and NH3 are neutral, so they're not going to affect the charge of the whole thing. Anyway, so that's about this one. Now you have to remember these equations because you're going to be specifically asked about this, and the question is going to be exactly the same. It's going to be exactly the same question, and you'll be asked to describe this exactly in the same way. Then the last one is the very last one is, if you add concentrated HCl. So what happens when you add concentrated HCl? It's pretty obvious. It's the Cl ligands will replace it. So concentrated HCl is added to copper sulfate aqueous. What happens now is a greenish yellow solution is formed. So you have to explain this with an aid of an equation. So the equation is going to be that you'll have Cu with 6 water molecules, and it's got a charge of +2. And Cl lines are going to come in. These ligands are going to come in, and they're going to replace the water molecules. Okay, so there's a reversible reaction, and 4 Cl lines take the place of the 6 water molecules. The overall thing will have a charge of -2, and the 6 water molecules are going to get knocked out. So this is your blue solution. And that's your greenish yellow solution. Technically, it's a yellow solution. The reason it appears green is that it's got some of this blue mixed into it. So what you see is something that's greenish yellow. So you're going to get this greenish yellow. You're going to get this greenish yellow solution. So that's all about ligand exchange reactions. All of them are ligand exchange, except for one of them. One of them is called precipitation. This one over here is precipitation, where a precipitate is formed. The other ones are all ligand exchange. This one is also now this one is also ligand exchange. So you've got all these reactions and all these equations, and you have to remember all of them. You have to, it's basically the same description that whatever happened over here, we're describing the same thing, but in the form of equations. ठीक है, तो ये आपके पास है, you've written down these equations over here. अब ये 4 Cls will replace the 6 water molecules, because I explained that Cl is a bigger ligand. So when you have Cl lines, you can't fit a lot of them. You can't fit 6 around the copper ion. Is that clear? अच्छा, अब ये कि जो नेक्स्ट चीज है, अच्छा, now this covers all your ligand exchange reactions, but remember that for cobalt it's going to be the same reaction. Okay, make sure you remember this, that we did write okay, cobalt is going to have the same exact complexes, and the same exact ligand exchange is going to happen with cobalt 2 as well. The only thing is that the colors are going to be different. अच्छा, तो सारों को क्लियर है ये?
यस सर.
अच्छा, अब इसके आगे ना, तो ये तो खाली याद रखना है. You have to just memorize all of this के ये equations exactly वही, और cobalt की exactly same है. Only thing is colors are different. ठीक है, now so that's one thing. So now there's, and we're done with colors and we're done with ligand exchange. Now there's another thing, since we are talking about ligand exchange reactions, there's a thing called stability constant. Okay, about these reactions. And one more thing about these reactions is, okay, these are reversible reactions. So remember this, that Lee-Shatler principle applies to these reactions. All these reactions that we have written above, uske upar na, that you'll get questions related to Lee-Shatler principle. So make sure you keep this in mind, that these are just like normal equilibrium reversible reactions. For example, you might get questions like, what will happen if you add water to it, for water to this equilibrium? Where will the equilibrium shift? The equilibrium kis side pe shift karega? It's going to shift in the backward direction, right? So your greenish yellow, and he'll ask you, okay, what is the color change that's going to happen? So if you add water to it, the equilibrium will shift backwards, and the greenish yellow solution will turn into a blue solution. You get the same in the above scenario as well, that it's a reversible reaction. So he might ask you, what will happen if you add OH to it? The equilibrium will shift backwards and it will form the pale blue precipitate back again. So remember, these are reversible reactions. So you might get questions related to equilibriums moving forward or backward, depending on what you're doing. If you decrease the concentration of Cl lines, equilibrium will shift backwards. If you increase the concentration of Cl lines, the equilibrium will shift forward in this case. तो इस तरह के भी क्वेश्चंस आएंगे इसके ऊपर. अच्छा, but the important thing is case stability, and this is an equilibrium constant. This is known as K stab. Achha, what is the stability constant? Stability constant is the equilibrium constant so this is the equilibrium constant for the formation of a complex ion in aqueous solution. Complex ion in aqueous. I mean, you should know the definition as well. So it is the equilibrium constant. So it's just an equilibrium constant. What is the equilibrium constant, by the way? Equilibrium constant is, you've got a reversible reaction. So it's the concentration of the products divided by the concentration of the reactants. Now that's what your equilibrium constant is. So I'll explain what this means. What this means is, you've got an aqueous solution. Let's take the same copper, and it's got 6 water molecules attached to it, and it's got +2 charge. So remember, it's the formation of a complex ion in aqueous solution. Aqueous solution is this. Any ion, metal ion, will be forming a complex with water in an aqueous solution. Now we're going to try to form a complex. So what I'll do is, or I'm going to try and form another complex. What I'm going to do is, I'm going to add Cl lines to it. वो जो ऊपर reaction है वही reaction है, ठीक है? So I'm going to add Cl lines to it. So what will happen is, okay, when I add Cl lines, the water molecules are going to get knocked out, and another complex is going to be formed, and that's CuCl4 2-. और वो 6 के 6 water molecules, they're getting replaced. Okay, so all 6 of those water molecules, they get replaced. Now we've got this happening. Copper with 6 water molecules, and the Cl lines are going to knock out the water molecules. So this statement, does it make sense that it's the formation of a complex ion, which is this one, in aqueous solution? You had an aqueous solution where copper was forming a complex with water molecules, and the water molecules got knocked out by Cl ligands, and you get another complex. So it's the equilibrium constant for this reaction. So what is the equilibrium constant? K stab or stability constant in this case. So how do you write the equilibrium constant? It's going to be product concentration, so it's going to be CuCl4. ठीक है, CuCl4 और 2 minus है उसकी concentration multiplied by water concentration. Actually, the thing is that water, since everything is aqueous, in aqueous solution, water is going to be taken as a constant, or water's concentration is ignored. Remember, if you remember AS ka na equilibrium constants, if you remember that, whenever you have aqueous solution, the water is in such a large excess that its concentration is considered to be almost constant. So यहाँ पे ना water, because it's in such a large amount, because the whole solution is made up of water, कि उसके moles थोड़े से ज्यादा हो जाएं, थोड़े से कम हो जाएं, it doesn't really matter. ठीक है, its concentration kind of pretty much remains constant throughout. So CuCl4 2 minus divided by the reactants. The reactants are copper with 6 water molecules having a charge of +2. And you'll have Cl minus 1 with the power of 4. So if you remember equilibrium constants, उसमें क्या होता था कि it's the ratio of the products to reactants and हाँ जी
सर हम तो ट्रांजिशन एलिमेंट्स कर रहे थे, इसके अंदर स्टेबिलिटी कांस्टेंट आ गया.
हाँ वो तो मैं मिस कर दिया शुरू वाला. हम कल जो हमने किया था ना, मैं जल्दी से रिकैप कर देता हूँ. कल हमने किया था कि ये सारा ना हमने कहा था कि वाटर मॉलिक्यूल्स हैं तो OH आयंस डालोगे तो क्या हो जाएगा, OH आ जाएगा. वाटर मॉलिक्यूल्स हैं उसमें अगर आप ना Cl आयंस डालोगे तो क्या होगा, Cl आयंस आ जाएंगे उसके अंदर. ठीक है, NH3 डालोगे तो NH3 आ जाएंगे उसके अंदर. ठीक है, और कलर्स चेंज होते रहेंगे. ये ग्रीनिश येलो है, ये डीप ब्लू है. ठीक है, तो मैंने उन्हीं की इक्वेशंस बनाई कि कॉपर के साथ ना 6 वाटर मॉलिक्यूल्स होंगे, राइट. तो अगर कॉपर के साथ 6 वाटर मॉलिक्यूल्स होंगे, OH आयंस डालोगे तो OH आ जाएगा. तो योर कॉम्प्लेक्स विल बी दिस वन. फिर वही था कि कॉपर के साथ अगर वाटर मॉलिक्यूल्स होंगे और NH3 डालोगे तो उसकी जगह क्या आ जाएगा, NH3 आ जाएगा. you'll get a deep blue solution, right. और मैंने कहा all these ligand exchange reactions are reversible reaction. कॉपर के साथ 6 वाटर मॉलिक्यूल्स होंगे, Cl आयंस डालोगे, Cl आ जाएगा. क्लियर है?
Yes, sir.
तो मैंने कहा these are all reversible reactions. When they are reversible reactions, so there's going to be an equilibrium constant. So whenever you have a ligand exchange reaction, that reaction itself is a reversible reaction. यानी वो रिवर्स भी हो सकता है कि आप उसको ना उल्टी डायरेक्शन में भी लेके जा सकते हो. कि अच्छा, तो आप उसको ऑपोजिट डायरेक्शन में भी लेके जा सकते हो कि व्हाट यू कैन डू इज के वाटर वापस ऐड करो तो वापस वो बन जाएगा. ठीक है, तो stability constant is the equilibrium constant product over, I mean it's the product concentration divided by the reactant concentration. हाँ जी
सर क्वेश्चन है वो जो सर वो कल वाला जो 4 अक्टूबर का जो लेक्चर है ना सर, वो उसके अंदर एरर आ रहा है.
मैं वो देख लेता हूँ, शायद वो ही ना. एक सेकंड, जो मैं क्लास के एंड में देखता हूँ. ठीक है,
ओके.
अच्छा, stability constant, is that clear? Siddha, is this clear? Arisha?
Yes, sir.
So this is stability constant, and now when you have a large value of equilibrium constant, when you have a large value, if it's a big value, what that means is that there's going to be more products. That means there's a very good chance of the complex forming. So large value indicates more products, right? That means you've got a stable complex. And what that word means is that there's a much greater chance of the complex forming. So more chances of the formation of the complex. So you've got a pretty good chance that this complex over here is going to be it is going to be formed. Okay, so when you have a large value, there's a much brighter chance of this complex forming. Otherwise, there's going to be a smaller chance of this complex forming if it's a small value. Okay, so a large value of K stability indicates that you've got a very stable complex and it's very likely to form. Small value indicates that it's not going to form. Okay, small value exactly uska opposite show karti hai that the reaction favors the backward reaction. The vice versa, small value shows that the backward or the reactants are favored. And it would be very hard to form the complex. So less chances of this complex getting formed. Okay, so there's going to be very less chance of the complex getting formed. So is this clear? Stability constant. All ligand exchange reactions, they're going to have a stability constant. Every complex will probably have a stability constant. Like if I just Google this, so you'll get stability constant values for different reactions or different ligands. Okay. अच्छा ये वाला कर लेते हैं अगर हाँ ये वाला अगर देखो कि now these are all these complexes and remember it's these complexes are getting formed from the aqueous solution. Like Fe was surrounded by water, now it's surrounded by this ligand. Cu was surrounded by water, now it's surrounded by NH3s. Cobalt was surrounded by water, now it's surrounded by NH3. As I look at the stability constant, so which one is the one that's most likely to be formed? In Salome, which one is the most stable one that has a very high chance of getting formed? इस सालों की वैल्यू नजर आ रही है ना
Sir, Hg?
ये वाला ठीक है exactly. It's 10 power 41. That means a lot of products is going to be formed in this case. And this one is the least likely to be formed. कि अगर आप Fe or water, Fe aqueous होगा ना, if you add SCN to it, there's a very small chance of this getting formed. बहुत कम chances है. ठीक है? Is that clear? Okay, we can ignore the instability constant. We don't need that. We can just work with the stability constant. खैर वो common वाले कुछ ये तो वो हैं थोड़े से जिनके साथ हम डील कर रहे हैं. नहीं खैर इधर मिलना मुश्किल.
सर इंस्टेबिलिटी हमारे कोर्स में नहीं है.
नहीं इंस्टेबिलिटी कांस्टेंट नहीं है लेकिन वो उसका उल्टा है. इट्स एग्जैक्टली द ऑपोजिट राइट. तो ठीक है. इज दिस क्लियर? स्टेबिलिटी कांस्टेंट. बाकी पास पेपर प्रैक्टिस करेंगे उसमें देखते हैं. सो सिंपल आइडिया. ठीक है. देयर इज नो कॉम्प्लिकेशन. This is stability constant. Every complex is going to have a stability constant value. खैर अगला वाला पार्ट थोड़ा सा कॉम्प्लिकेटेड तो इधर ही पास पेपर में देख लेते हैं कि थोड़ा सा पास पेपर क्वेश्चंस देख लेते हैं. Just to explain to you that what kind of questions you're going to get kind of transition metals. अच्छी खाली जो चीजें अभी हमने की हुई हैं, only those things. It's exactly the same question. Copper with 6. So just a few questions, practicing a few questions. Remember, I told you it's going to be exactly the same question. There's hardly going to be any difference. Copper with 6 water molecules, you're adding NaOH to it. Okay, so ionic equation, type of reaction, color of the product. So what happens? Okay, you've got copper with 6 water molecules plus 2. You add OH ions what will happen that two of the water molecules are going to get replaced by OH, and the whole thing will become neutral. It will form a pale blue precipitate, and two of the water molecules are going to get knocked out. The type of reaction, that's a precipitation reaction. I told you, case a precipitate is getting formed. Color of the product, it's a pale blue precipitate. Pale blue. It's a pale blue precipitate, and the next one, what happens if you add a hydrochloric acid? You have the same water, copper with 6 water molecules, and your copper with 6 water molecule gets replaced by Cl ions, and you get CuCl4, and it's 2 minus. So remember, cobalt ke saath bhi, it's exactly the same reaction. The color is the only thing that's going to be different. So CuCl4 2 minus, and there's 6 water molecules, and type of reaction, that's Ligand exchange. And the color of the product, that's greenish yellow solution.
Sir?
हाँ जी.
Sir, ligand exchange कौन से reactions को कहते हैं?
जिसमें ligand change हो रहा है ना, ये सारे reactions, अच्छा ये सारे reactions ligand exchange थे ना. इनमें से except for one of them is not ligand exchange. This one is called precipitation. क्यों होता ये कि जब वो, अच्छा इसका मैं थोड़ा सा explain कर देता हूँ कि why this is not called ligand exchange, because an exchange is not happening. I'll explain what happens just a little bit. कि होता ये कि जब वो दो OH ions आते हैं ना, what actually happens is when those two OH ions they come in, तो ये वाला जो section है ना, copper 2+ and the OH ions, the whole thing becomes neutral. क्योंकि copper is 2+, OH is -1, OH is -1. So this is copper hydroxide. It becomes neutral. When it becomes neutral, तो वो क्या करता है? Water को दोबारा attract नहीं करता. So what happens is all these water molecules they kind of leave. ठीक है, ये वाला water molecule भी चला जाता है. ठीक है, ये वाला water molecule भी चला जाता है, because there's no point. It's no longer going to attract it, right? क्योंकि this entire thing is no longer having any charge. क्योंकि overall ये neutral हो गया. तो इसलिए मैं copper hydroxide में ना वो जो 4 water molecules are, they're going to leave once the ligand exchange happens. Is that clear?
Yes, sir.
तो बस wrap up करते हैं एक सेकंड.
और सर बाकियों में जब वो अटैच होते हैं जैसे NH3 तो उस टाइम पे वो न्यूट्रल नहीं होता ना, राइट?
हाँ, वो न्यूट्रल ही होता है. सब NH3 आता है ना, तो वो फिर वो अभी भी +2 है, तो वो यानी इसका मतलब है all of them will still be attracted to it. तो इसलिए वो dissolved रहता है, वो precipitate बना देता है. The reason it forms a precipitate is because it becomes completely neutral. It no longer attracts the ligands. Well, ligands will eventually leave, and you'll just have a solid precipitate of copper hydroxide. ठीक है? So you write this, both of them are acceptable. ठीक है? So you don't have to go into that much detail about this. So that's the reason why it's not called ligand exchange, because exchange नहीं होता, वो ligands चले ही जाते हैं इनमें. ठीक है? तो यहाँ पे they don't leave. They actually get exchanged. ठीक है? इधर भी ना, they don't leave. They actually get exchanged. Is that clear?
Yes, sir.
तो बस ये बाकी क्वेश्चन थोड़ा सा आइडिया दे दिया था कि इट्स गोइंग टू बी एग्जैक्टली द सेम. मतलब इसमें कोई ज्यादा कंफ्यूजन की बात नहीं है. Whatever is written in the notes over there, it's going to be exactly the same. They're going to ask you exactly the same thing. ठीक है? तो चलो ठीक है, बाकी फिर वो कल कंप्लीट करते हैं.
सर
हाँ जी.
सर वो सिलेबस को मैं चेक कर रहा था सर, उसके अंदर लिखा हुआ था नर्स्ट इक्वेशन.
हाँ तो वो की थी ना.